Hello students, welcome to the part 2 of this lecture topic on free radicals and antioxidants. In the previous session, we learned what is a free radical. We identified a few characteristics of these free radicals. We also touched upon a few examples of these free radicals. Later in the chapter, we saw how many processes exists, both exogenous and endogenous, which are dedicating itself to development to the construct of these free radicals or to the existence of these free radicals. We've seen that some of these free radicals have got beneficial effects, such as the ones produced by the macrophages and neutrophils, and there are others who produce large amount of free radicals causing damage and destructions to various tissues and macromolecules. We are in the second part where we will be looking at the next three learning outcomes. For this chapter, we will be looking at what kind of a defense system exists against these free radicals which are produced in excess. We call them oxidative stress because most of these are oxygen radical. So the term commonly used is oxidative stress. Following this, we will look into the roles of free radical in various common clinical conditions. So they have been identifying a lot of clinical conditions which are found to be because of free radicals. And lastly, we will look at a few biochemical markers and how they are used to detect free radicals. All right, let's begin. All right, let's begin by looking at the classification. Now, classification of antioxidants is based on composition and mechanism of action. Based on composition, they are classified as enzymatic antioxidants and non-enzymatic antioxidants, self-explanatory. Moving on to the mechanism of action, they are classified as preventive and chain breaking. What preventive antioxidants means is that these are antioxidants that come into effect as soon as the free radical is generated, and they do not allow the free radicals or the oxidants to propagate. As far as chain breaking antioxidant is concerned, they prevent the further progression of free radical. That means to say, the free radical has already started showing its chain reaction by propagating and damaging the lipid molecule. These chain breaking antioxidants come in place in that particular stage of reaction, not allowing the free radical to carry on its effect. Okay, let's move on to the next slide. Let's look at the first classification, free radical scavengers enzyme system. These are enzymatic free radicals that exist. What basically happens is when the free radicals are generated, there comes in a system of enzymes which collectively work together and reduce the impact or the effect of free radicals. So let's look at a few reactions that happens in our system. The first one is this particular enzyme, superoxide dismutase. Now we all know superoxide refers to O2 dot negative. The dot indicates an extra electron, the negative sign indicates the negative charge of the electron. So what happens is this particular enzyme takes two such superoxides which are existing. Now you should assume that there are conditions where a lot of free radicals are generated, like people suffering from damages caused by cigarette tar or fumes or radiation, many other chemical antioxidant producing chemicals. So in that scenario, there's a lot of free radicals available, and there's a lot of these oxidants being formed or oxidate, and there's a lot of oxidative stress that is happening in the body. Now, in this situation, this particular enzyme takes two such superoxides and uses two protons to combine it together to form hydrogen peroxide, releasing one oxygen molecule. Now, we all know that superoxide is a very, very potent antioxidant, but so is hydrogen peroxide. So what do? we move on to the next line of defense. What happens here is that this milder version, so to say, of hydrogen peroxide, two such hydrogen peroxides are combined together by this enzyme called catalase, forming water and oxygen. So what exists as superoxide has now converted into water and oxygen, thereby neutralizing its effect as soon as it is produced. Now this is one such combination where these two enzymes, superoxide dismutase and catalase, work together to neutralize the antioxidants. There is another way in which the hydrogen peroxide is dealt with, that is by the presence of enzyme glutathione peroxidase. Now glutathione is a molecule which is present as a co-substrate or a coenzyme in this enzyme, for this enzyme glutathione peroxidase. Now if you look at this, glutathione, which is represented as G, has got sulfur, that's why it is S, holding hydrogen molecule. So one sulfur holds one hydrogen molecule. So there are two glutathione molecule which has got two sulfurs holding two hydrogen molecule. Now whenever this glutathione holds hydrogen, it is considered to be in a reduced form. So this is a reduced glutathione. In this reaction, glutathione peroxidase, which is an enzyme which takes care of this peroxidase, extracts two hydrogen from glutathione, adds it on to this hydrogen peroxide. So in that case, what happens is when two hydrogen is lost, this glutathione becomes oxidized glutathione. So reduced glutathione becomes oxidized. Now what happens to this two hydrogen which gets added to this hydrogen peroxide? It gets converted into two molecules of water, thereby neutralizing the oxidative effect of hydrogen peroxide. Now, interesting thing is that this particular oxidized glutathione has a way of getting reduced again, and this is where the next set of enzyme comes into picture, glutathione reductase, indicated here by GR. Now, this glutathione reductase takes the hydrogen from NADPH. Now, you all remember NADPH is very different from NADH. NADPH is obtained from HMP shunt pathway, where glucose passes through a series of reaction, and in that reaction one important enzyme is glutathione 6-phosphate dehydrogenase, the first enzyme in HMP shunt pathway, which generates NADPH from NADP, right? So this NADPH is a carrier of hydrogen. NADPH is different from NADH, where NADH is an energy producing molecule, whereas NADPH is a molecule which carries hydrogen. So this hydrogen carrying molecule gives away its hydrogen to convert the oxidized glutathione to a reduced form, so that it can be utilized in neutralizing the free radicals effect, and this is done by the enzyme glutathione reductase. So this is the second combination of enzyme which acts as a scavenger, that includes glutathione peroxidase and glutathione reductase working together. The first system is superoxide dismutase and catalase. So these enzymes all put together contribute to the enzymatic antioxidant pool existing in our system. Now let's look at what are the non-enzymatic antioxidants that are present in our body. Now here is a list of non-enzymatic antioxidants. We will not go into detail explaining all the non-enzymatic antioxidants. We will limit our understanding to just two important ones. The most important one includes vitamin E and vitamin C. I have not written vitamin E here because I will be spending some time in the next slide. So vitamin C has an ability to take the free radical and neutralize its effect. That means it's got the ability to capture the radical and not let it propagate, not let it move on. So it holds the free radical in a place. So we will look at this in the future slides. Then there is vitamin B3, which is which has ceruloplasmin, which is present in ceruloplasmin. And remember the role of iron in generating free radical? Well, this vitamin B3 neutralizes that, the effect of free radical or the generated by iron. The next is vitamin A. It helps vitamin E, which is a major antioxidant, to perform its function even better. Then there is beta carotene, a derivative of this vitamin A, which also acts as what we call chain breaking antioxidant, and it is very, very important in preventing heart attacks, because heart attacks, which normally involves the formation of atherosclerotic plaque, which is already seen in your lipid metabolism chapter, the bad cholesterol leading to atherosclerotic plaque. This beta carotene takes care of the formation of these plaques. Then you have caffeine, which also has got mild oxidants. We all have heard of green tea, which has been very popular. Now, what advantage green tea has is that it's got a high content of these antioxidants. And then the last one is uric acid, which is produced by our own system, also serves as an antioxidant by converting itself to allantoin non-enzymatically. Now, this is the conversion of uric acid to allantoin after it gets the free radical. Okay. Now, these are a list of free radicals that are existing in our system, or it can be taken in our diet. Alright, what we saw in the previous slide are the classification based on their composition. We had a list of antioxidants and which is basically enzymatic, and then a list of non-enzymatic antioxidants. One very important non-enzymatic antioxidant, which includes vitamin A, will be explained in this second classification, because it's got a better role under this classification. This classification talks to you on how antioxidants can be divided based on its functional property. The first one includes preventive antioxidants. So we all know that the damage produced by reactive oxygen species, or free radicals, or antioxidants, however it may be called, is quite well documented. There are two types of antioxidants which play a role in the progression of this disease. One is called preventive antioxidant. Simply put, they inhibit the initial production of free radical itself. They include a list of all these. Now, you've noticed that catalase and glutathione peroxidase, how they form, they are reflected in the enzymatic antioxidants. Well, peroxidase also is another very important antioxidant, which takes one hydrogen peroxide and converts it into a very harmless water molecule, just like how catalase did that. The other non-enzymatic antioxidant which prevents the formation of free radical includes DPTA, which stands for diethyl triamine pentacetate and ethylene diamine tetraacetate. We will not go into the detail of how they act as antioxidants. Just understand or know that they are the preventive antioxidants includes the enzymatic system, which was explained earlier, and a few non-enzymatic antioxidants. All are examples of preventive antioxidants, and the list is quite exhaustive, but I have limited myself to these 5. The second type of antioxidant based on their function includes chain breaking antioxidant. Now, this chain breaking antioxidant is based on its function that includes suggests that these antioxidants are a group of compounds which does not allow the effect of free radical to propagate. So what they do is, once the free radical is formed and generated, the chain breaking propagation of this free radical is blocked by these chain breaking antioxidants. So they inhibit the propagative phase of the free radical, and the examples include superoxide dismutase, uric acid, and vitamin E. Now, superoxide dismutase, we've already reflected upon its function in the earlier slides. Let's look at vitamin E in a much more detailed fashion. We will learn a lot of vitamin D under the chapter vitamins, but just to understand this context, vitamin has got a tocopherol system, a ring system which is called tocopherol ring, very unique. Its function is based on that particular structure. Its structure basically has got an OH group. This structure of tocopherol has got an OH group in itself. So what happens is, when the free radical is generated and propagated, remember the fatty acid that is getting damaged. We had represented this fatty acid damage as ROO dot. That means the fatty acid is damaged and it's carrying that free radical. Now, if left unchecked, this free radical goes on to the next new R group, converting it into R or ROO molecule. Now, what happens is, what you need to understand is that vitamin E, which is alpha tocopherol, is placed in between these membranes. Most of the cell membrane has got vitamin E present in them. Now, what this does is this: as the free radical is propagating, it meets one of these vitamin E. It meets the vitamin E. Now, this vitamin E now takes the free radical from the damaged fatty acid, and this becomes a free radical charged vitamin E carrying free radical. Now, the advantage of this particular capture is this, that unlike other fatty acids which gets damaged and allows the free radical to jump to the next fatty acid, vitamin E holds the free radical to itself. Now, what's the advantage? Now, imagine the vitamin E holding the free radical, and assume that there is another free radical damage happening in the other direction. That means there's one free radical coming from the alternative direction. Now, there is this vitamin E containing the free radical has got one electron which is unpaired. Now, there's another unpaired electron traveling in the opposite direction. Now, this particular free radical carrying another electron, unpaired electron, meets this particular vitamin E carrying unpaired electron. So, when these two unpaired electrons join together, they get paired, and as a result, the final product which is formed is an inactive product. And that is how the propagation of anti-free radical or oxidants or oxygen species is stopped, is inhibited. So, this is the role of free radical in dealing with propagative phase of antioxidant. I will explain this vitamin E in a much more illustrative manner. Now, look at this particular diagram. This is the phospholipid layer which we all notice, which we are all very familiar with. Within this phospholipid, you have vitamin E that is spread. Now, you know that the free radical which is generated, it's propagating by damaging the fatty acids one after the other. This is one such damaged fatty acids which is damaged because of this one electron that is escaped out of the orbit. You see, the electron that is escaped is caused the damage to the free radical, the fatty acids over here. Now, look at this picture over here. It says that this extra electron which is carried, which is escaped, is now trapped by this vitamin E molecule. Now, vitamin E which is present in the membrane holds the free radical, not allowing it to propagate. So, the free radical which is normally destroying the fatty acid does not further have its effect. That's how the alpha tocopherol vitamin E has its chain breaking antioxidant effect. Now, there are many ways in which the free radical which jumps on to the vitamin E gets neutralized. One way is what you saw in the earlier slide. It waits for another free electron to combine together to form a pair. There's another system that exists to deal with this particular free radical, and that includes the combination of vitamin C. Now, in this we call them as A teams, which against the A teams defense system. That means this is a teamwork which includes vitamin E, vitamin C, and the glutathione molecule which we've already seen. Now, what happens is the oxidants or the free radical which is propagating is captured by vitamin E. So, the tocopherol which is there becomes a tocopherol radical having the free radical in them. Now, what this tocopherol does is it carefully gives away its radical to vitamin C. And what vitamin C is vitamin C is an ascorbate molecule. Now vitamin C, when it converts, when it takes this electron, it becomes DHA, dihydroascorbate. Now this ascorbate carrying the free radical gives away the free radical, forming hydrogen peroxide, and this hydrogen peroxide enters into this molecule of glutathione reductase, which converts the hydrogen peroxide into 2 water molecule using 2 hydrogen from glutathione. Now in this system, the hydrogen comes from reduced glutathione becoming oxidized glutathione, and this oxidized glutathione again goes back this glutathione the glutathione peroxidase neutralizes the free radical, and the glutathione reductase converts the oxidized glutathione to reduced glutathione, taking it from NADPH molecule. So this is a system that is in place, and this defense system, I would like to call it as A-team defense system, an absolutely foolproof defense system that exists in our body. Alright, now in spite of this defense system existing, in condition where the oxidants or the free radical is produced in such high quantity, then the damage to the tissue starts manifesting as clinically manifesting. So now let's look at this one interesting concept called oxidative stress. We have now understood that we have a lot of system which produces reactive oxygen species on one end, and then we also have a defense against it in the form of antioxidants. So the reactive oxygen species that build in your system includes hydrogen peroxide, superoxide ions, hydroxyl radicals, nitric oxide, and many more. And on the other hand, we have a lot of defense system which includes enzymatic and non-enzymatic. Now what happens is, in our system, whenever there is excess production of reactive oxygen species, then the balance shifts towards this. When the balance shifts towards this, there's a lot of free radical existing in the system which is not being able to neutralize by the existing antioxidants. Then we call that the system is in oxidative stress. Another scenario can exist where the oxygen free radicals or the reactive oxygen species are produced in normal amounts, but the presence of antioxidants is reduced. Let's say dietary, let's say nutritional deficiency or malnutrition or inappropriate unbalanced diet where you don't take proper vitamins in your system. All these things will reduce the amount of antioxidants present in our body. What this results is, it shifts the balance towards making a lot of free radicals unneutralized, and in this situation also this situation also leads to oxidative stress. So oxidative stress is a condition where either the production of free radical is very high or the availability of antioxidant is low. This is called oxidative stress. Now in this situation, a lot of clinical manifestation has been observed where whenever this oxidative stress is high, they start manifesting. So what are the clinical significance in this case of oxidative stress? First one, we will discuss a little bit very briefly on atherosclerosis. We all know that there's something called LDL, and LDL is a low density lipoprotein, which is a type of lipoprotein which is often called bad cholesterol. Now what do you mean by this? Why is it called bad cholesterol? Now why the LDL basically carries a lot of cholesterol in its structure. Now this molecule is transporting cholesterol back to the liver, and during this process, if these LDL has got the ability to get affected by free radicals. Once they get affected by free radicals, they become oxidized free radical. The effect of free radical converts normal LDL to oxidized LDL. This changes the property of LDL, the chemical property. Now, this normally LDL is transported freely in the blood vessel, but in the presence of oxidized LDL, the LDL becomes very sticky. So it gets stuck onto the LDL, to the blood vessel, and then later on it develops by traveling into the subintimal layer of many large arteries such as aorta, coronary vessels, or cerebral vessels. And once they enter into the tunica intima or subintimal layer, they start accumulating over there. Once they start accumulating over there, they are attacked by macrophages. So the macrophages come in sensing that there's some kind of a damage happened, and it sees this oxidized LDL and starts gobbling up this oxidized LDL. So once it gobbles up the oxidized LDL, this macrophage is converted into foam cell, and this foam cell starts to increase in number and size, and once it starts increasing to a larger extent, they start blocking the blood vessel, and that is when you say that there is a formation of atherosclerotic plaque. So it has been well established that the formation of atherosclerotic plaque, one of the more important reason is generation of free radical. A lot of free radical exists, or there is a lack of antioxidants in the system, which together causes damage to LDL cholesterol. The next clinical significance is role of free radical in aging. Now we all know that aging is a very natural process, but why it is natural and how it becomes natural? Well, it is free radical that makes it pure natural. Now, aging means most of the systems are slowing down. The process of the function slows down due to various metabolic changes. Now, these changes are brought about, or is now well studied, to establish a lot of significance, a lot of contribution is from free radical. Now, what happens in aging? Now, you've noticed that the elderly people have got some kind of a brown spots on their skin. Let's take that one simple example. Now, these brown spots are basically lipofuscin pigments. Now, what happens is the free radical that is generated in the system through their lifetime, they are affecting the melanin pigment on the skin, and a few spaces which have got this particular pigment affecting the melanocytes, they produce lipofuscin, and these are what converts it into the dark brown spots that you see on the skin. The second example is development of cataract. Now, you know that cataract development is very common in elderly age group. The reason for that is there's some kind of a photochemical generation of ROS species, like the presence of harmful radiations or harmful rays, which allows the formation of cataract. Basically, the lens, in the presence of these free radicals, starts becoming opaque, which is supposed to be transparent and translucent, becomes opaque due to the presence of free radicals, and that's how they develop cataract. Now, free radicals' role in inflammation has also been very extensively studied. Now, what you will notice is in all these conditions, which are either inflammatory conditions or infections, they have found a very significant rise in the amount of free radicals in the system. So there is a strong association of free radical and its damage that it causes whenever there is inflammation. I will not go into the detail of how that happens. All right. Next is the role of free radical in developing emphysema. Emphysema is a clinical condition where the alveoli, they become dilated and they do not have their functional property of contracting. So the balloon kind of effect of the alveoli is not there. Now, this emphysema is most of the time noticed due to associated with cigarette smokers. So basically what happens in cigarette smokers, the alpha 1 protease inhibitor which prevents the damaging effect of protease is not there. So this enzyme called alpha 1 and protease inhibitor is deficient. Now why it is deficient? It's because cigarette smoking generates free radicals which damages this enzyme alpha 1 protease inhibitor, thereby allowing the alpha 1 protease enzyme to continue damaging or eating up the proteins in the alveolus. And when the protein that is preventing the collapse of the alveoli is increasing in number, the alveoli, which is originally supposed to be contracting or having stable structure, no longer has a stable structure. So that is how it results in emphysema. So smoke, which is present in the free radical which is present in smoke, affects the enzyme protease inhibitor, leading to formation of emphysema and thereby lung damage. Then there is also the damage of free radical, the DNA, damage on the DNA by free radical, which leads to malignancy, and also during radiotherapy irradiation, which is most of the time as a treatment, used as a treatment modality in cancer, also can cause cell death. So there's a lot of work done on the effect of radiation in producing reactive oxygen species. So these are a few commonly studied associations of free radical with cellular damage, but a tremendous amount of work has been done in its role or contributing factor in diabetes. So we'll pay attention to that particular complication of why people with high sugar land up with a lot of complications affecting multiple organs. So this is what it is. This is just a overview of how free radical plays a role in diabetic complications. Now hyperglycemia means high blood sugar. So once there is hyperglycemia, this hyperglycemia it raises what happens to the intracellular glucose. The intracellular glucose is reduced, and in this state of hyperglycemia, the increased circulating sugar level produces a lot of what we call advanced glycated end product. AGES stands for advanced glycated end product, which are abnormal glucoses. So these glucose and glucose containing proteins go ahead and start damaging the proteins on various tissues. It can be renal tissue, nerve tissue, or whatever tissue. So this advanced glycated end product starts damaging various proteins on various tissues, changing their functions and damaging the tissues. This age or advanced glycated end product also, when it is increased in concentration, damages various connective tissues, various signaling systems like cytokines and growth factors. Both of these, altered cell function and damage to various tissues, results in complications of diabetes. Now, what you might have heard that diabetic people often have got problems with eyesight. They develop diabetic retinopathy, or they develop diabetic nephropathy, or they develop diabetic neuropathy. So damage of all these tissues is basically through formation of advanced glycated end product. So the system works. There is a presence of advanced glycated end product because of raised blood glucose affected by free radicals. There is another pathway which explains the mechanism of damage due to raised blood glucose levels. That includes this aldolase reductase system, where increased hyperglycemia converts a lot of glucose into sorbitol, and these sorbitols will again alter the reduction and oxidation potential of various molecules, which further generates a lot of free radicals that in turn alters the cell function and ultimately complicating the diabetic status. So the reason why diabetes causes a lot of complication is because of the availability of advanced glycated end product and abnormal glucose molecule, or the production of sorbitol. So these are the two main culprits in which are responsible for complicating diabetes. Now let's move on to the next topic on what are the oxidative stress parameters existing in our body. Now we have understood what is free radical and how it affects our system. We've seen how antioxidants are playing a role. Now what we are going to do is we are trying to use this knowledge. Now what we know is that there is a defense system that is existing in our body. Now we can reduce the oxidative effect by increasing the defense system. For that we need to identify when is oxidative stress is starting to show its effect, and to what extent is this stress existing. This is only possible when we take a sample and of our blood sample or any tissue sample and study the amount of free radical that is present in the body. And that is the intention of this slide, where we assess the oxidative stress by measuring a few parameters. Now, measuring free radical directly is impossible because it's got a very, very, very short half-life. So you cannot capture a free radical and measure it. So what we have to do is we have to measure the damage that free radical leaves behind. So more the free radical, more the damage that is existing. More the damage existing, we take it as a assumption that there is a lot of free radical. So these are a list of such damaged product. Now this is where this particular product called malondialdehyde comes in very handy. Now malondialdehyde is a damaged byproduct of lipid fatty acids. So we measure MDA, and more MDA indicates more free radical in the system. Similarly, we just saw how advanced glycated end product, when they are increased in concentration, that means there is a lot of free radical there. So there's something called advanced lipoxidation end products. Again, these are all parameters that indicate excessive generation of free radicals. All right. So once we identify these free radicals, then we can start substituting a lot of antioxidants in our diet, or as a treatment to reduce these defects. These are a list of antioxidant markers that exists in our system. We take glutathione and see how is the glutathione content is. So if it's reduced, then the damage is obvious. We take oxidized glutathione. If it is increased, that means the glutathione peroxidase, the glutathione reductase or the glucose 6-phosphate dehydrogenase is deficient. So that's when we take a note of it and we make the corrections. So these are antioxidants, again other antioxidant markers that exist for us to estimate the damage of. So at the end of this, we have understood what is free radical, how it is generated, a few characteristic features of them, a list of all the free radicals that exist in the system. Why is it damaged? Why is it so dangerous? How it damages various macromolecules? What kind of a defense system exists in our body? How clinically we can correlate it with various clinical system or circumstances, and how do you measure these free radicals? So this is what we've learned at this end of this particular lecture series. Once again, thank you for participating in this podcast. I would highly encourage you to look up all the links given to further strengthen your understanding on free radicals. Okay. Good luck and carry on learning.